Hello everyone. Today we will see the sample paper questions. This is the general pattern. First question, which of these is also named for ethanol? So let's see which one is this. Acetaldehyde. Acetaldehyde is an aldehyde. So this is CH3CHO, the formula. Next is formic acid. The formula is SCOOH. It is carboxylic acid. Then acetone. CH3COCH3. So this is a ketone. And next ethyl alcohol. CH3CH2OH. So here we have OH is the alcohol group. So this is either we can say ethyl alcohol or the name is ethanol. So the answer for this question is ethanol. Next question. Which of the following is not a straight chain hydrocarbon? So straight chain, it means it should not have any branching. So what are hydrocarbons? Compounds which contains carbon and hydrogen are known as hydrocarbons. Let us count the hydrocarbon chain. 1, 2, 3, 4, 5 and 6. So this is a continuous chain. Next, we can count 1, 2, 3, 4, 5. So in second carbon we have a methyl. This is a side chain. Next, 1, 2, 3, 4, 5, 6. This is a continuous chain. Another 1, 2, 3, 4, 5, 6. Again, this is also a continuous straight chain. So the answer is B. Only it has one side chain. That is why this is not a straight chain hydrocarbon. Next, substance X is formed by oxidation of aldehyde. What will be the action of substance formed on the litmus solution? So oxidation of aldehyde. So aldehyde, when it oxidizes, it forms acid. So this is the general rule that whenever an aldehyde HCO, this is H, whenever it oxidizes, oxidation of aldehyde will always give acid. So carboxylic acid. So we will get here acid. So acid, what is the function of acid? Acid will turn blue litmus to red. So what will be the action of substance formed on the litmus solution? The substance formed is acid. So first option, no action on litmus solution, turns blue litmus red, turns red litmus blue, or none of the above. So the answer for this is turns blue litmus red. Always remember that the acid will turn blue litmus paper to red, whereas bases will turn red litmus to blue. So remember BB. So bases, red litmus to blue. Sodium bicarbonate solution is added to dilute ethanoic acid. It is observed that, so sodium bicarbonate, what is the formula? NaHCO3. It is added to dilute ethanoic acid. C2, you can write CH3, CH2, C. So next question, sodium bicarbonate solution is added to dilute ethanoic acid. It is observed that, so sodium bicarbonate NaHCO3 plus CH3COOH. So what you will get? We will get CH3COONA, sodium salt of acetic acid, plus CO2 plus H2O. So which gas is evolved? Carbon dioxide gas is evolved. So whenever sodium bicarbonate solution is added to ethanoic acid, or this is ethanoic acid, then we will get sodium salt of carboxylate and carbon dioxide and water. So the answer is a gas evolves. This is the answer. Next, which of the following contains functional group OH? So functional group OH, first is propane. So propane is an alkane. Propanol. Propanol. Propanol means CH3, CH2, CH2OH. So it contains OH group. The propane formula is CH3, CH2, CH3. This is propane. Next, ethanoic acid. CH3, COOH. Next, ethanol. CH3, CH2OH. So the OH group is present in propanol and it is present in ethanol also. So the answer is B and D. So the answer is B and D. This is the answer. Next question. The chemical compound present in a fruit. So fruits contains mostly esters only. So what is the formula for ester? The functional group is R, C double bond O, O and R, where R is an alkyl group. So here let's see which one will be similar to this. First is methyl 1R group, C double bond OO, carboxylate group, and then C2H5 1R group. So it contains this RCOOR. This one is propanoic acid. This is ethanol. So the chemical compound which is present in fruit is esters. So first the answer is A. So it is ethyl acetate. The name is ethyl ethanoate. Next, match the following with correct response. Alcohol. So the alcohol general formula is ROH. So this is alcohol, ROH. Aldehyde contains CHO group, this one. Ketone contains C double bond O, and haloalkanes contain RX, where X is the halogens. That is, they are the group 17 elements. They are fluorine, chlorine, bromine, iodine. Let's match 1. 1 means C. So 1B, it is not there. Again 1A, discard it. 1D, no. Let's check this. 1C, 2 is aldehyde, CHO, 2 is B, 3 is D, 4 is A. So the answer is D. Next, match the following with correct response. Soaps. So what are soaps? Soaps are sodium salts of long chain of fatty acids. The fatty acids may be palmitic acid. The formula for this is C15H31COOH, or stearic acid. The formula is C17H35COOH, or folic acid, C17H33COOH. So hence we can say that the general formula of soap is RCOONA or RCOOK. So soaps are sodium salts of long chain of fatty acids, or they are also the potassium salts of long chain of fatty acids. So one will be the answer D. Detergents are sodium salts of long chain of sulfonic acids. Next, the reaction of acetic acid with metal hydroxide. So remember, whenever acid reacts with base, so we will get salt plus water. So here acetic acid CH3COOH plus sodium hydroxide. So here we will get water will be removed, H2O, plus we will get CH3COONO, sodium salt of carboxylic acid. The name is sodium acetate. So this reaction is known as acid-base reaction is known as neutralization reaction. Neutralization reaction. So the answer for this is C only. Next for fourth, the reaction of acetic acid with alcohols. Always remember, whenever acids react with alcohols, so what you will get? You will get esters. So here CH3, COOH plus C2H5OH. This is acetic acid. This is ethanol. So we will get again here we will get this. We will CH3, COO, C2H5. So this is ethyl acetate, or the name is ethyl ethanoate. The IUPAC name for this compound is ethyl ethanoate. So this is acetic acid, ethyl alcohol forms ethyl ethanoate or ethyl acetate. So this reaction is known as esterification reaction. Why in this we will get the product is ester. So hence this is the answer is the B. So let's check 1 we have D. So 1 D is there, 2 A, 3 is C, 4 is B. Hence the correct answer is C. Next, how would you name the following compound? CH3CH2. So this is ethyl and this is halogen bromine. So the name is ethyl bromide, or IUPAC name is bromoethane. Next compound, HC double bond OH. So the common name is formaldehyde, and IUPAC name, since it contains only one carbon, so IUPAC name is methanol. Next compound. Let's number the carbon 1, 2, 3, 4, 5, 6. 6 means hex. Then there is a triple bond in the first carbon. We have to count this triple bond for the first, not for the second. So triple bond means the name ending will be "-ine". So hex hyphen 1 hyphen "-ine", because 1 indicates the position of the triple bond. Draw the electron dot structure for propanol. Propanol, first you write the structural formula for propanol. CH3. In the middle carbon, we have a ketone group. Then again CH3. This is propanol. Now write the dots for carbon electron. This is electron of oxygen. This is the electron of this carbon, electron of this carbon. Again, electron of carbon, electron of hydrogen. Electron of carbon, electron of hydrogen. Electron of carbon, electron of hydrogen. Then electron of one carbon, electron of another carbon. Electron of carbon, this is hydrogen. Electron of carbon, this is hydrogen. Electron of carbon, and this hydrogen. Now circle all the electrons for this also. All electrons. You have to circle all the electrons. Then for this hydrogen, this one. For here, you have to do like this. Then for this, like this. For this, all hydrogen and carbon electrons. This is how you have to draw the electron dot structure for propanol. Next question. Substance X is formed by reaction of carboxylic acid and alcohol. It is used in making ice creams, cold drinks, perfumes, and flavoring agent. Name X. So just now I have told that whenever carboxylic acid reacts with alcohol, then water is removed and we will get ester, R, C double bond O, O and R dash. R means one alkene and this is another alkene. So the product will be get esters. So this is acid, carboxylic acid. This is carboxylic acid and this is alcohol. So we will get ester. This reaction is known as esterification. So in this, the ester, these are the smell is very sweet smell they have. And they are used for making ice creams, cold drinks, perfumes, and a flavoring agent. Hence the name X. So the name X will be what? Ester. So tick this one. Next question. Write the molecular formula of first two members of homologous series having functional group OH. Also draw their bond line structure. Functional group OH. Functional group OH means what is this? These are alcohols. So what are homologous series? In which the adjacent members differ by one CH2 group. They are known as homologous series. Whether it may be alkane, alkene, alkyne or any functional group like alcohols, carboxylic acid, the adjacent members will always differ by one CH2 group. That is known as homologous series. So we have to draw first two members for the alcohol. So first member of the alcohol is methanol. Methanol. So we will write CH3 and if suppose this is H, this is methane. So OH. So this is methanol. So H is replaced by OH group. This is methanol. This structure is known as bond line structure. This is known as bond line structure. Then the molecular formula for this structure is CH3OH. This is the molecular formula. Next homolog is ethanol. Ethanol means where we have two carbon. So hydrogen, 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 OH. So this is ethanol and this is again bond line structure this is and molecular formula is count C2, 1, 2, 3, 4, 5, H5 and OH. So this is the molecular formula for ethanol. So hence both just now check CH3OH and C2H5OH. The difference here in 1C, here we have 2C, means difference is 1C. And hydrogen here 3 plus 1, 4. Hydrogen here 5 plus 1, 6. So 6 minus 4 is hydrogen 2. Oxygen, oxygen. Hence both the members differ by one CH2 group. So these are the homologous first two members of homologous series of the alcohol, that is methanol and ethanol. Next question. A student is performing an experiment to study the properties of the acetic acid. Answer the following questions. Name the substance he must add to acetic acid to produce carbon dioxide. CH3COOH is the acetic acid. Give the relevant chemical equation for this reaction. How would he test CO2 gas in the laboratory? And how is the presence of an acid tested with strip of red litmus paper? So these all we study under the reaction with carbonates and hydrogen carbonates. So first is acetic acid reacts with sodium carbonate. We will get sodium salt of carboxylic acid. So this is sodium acetate. plus water plus carbon dioxide gas is released. Next, acetic acid reacts with sodium hydrogen carbonate. Again, we will get sodium salt of acetic acid, that is sodium acetate plus water plus carbon dioxide gas. So in both the reaction, whenever the acetic acid reacts with sodium carbonate or if it reacts with sodium hydrogen carbonate, then we will get sodium salts of acetic acid. So here the gas which is released is carbon dioxide gas. Now, how we will test the carbon dioxide gas? So, whenever we pass this carbon dioxide gas in lime water. So, what is lime water? It is calcium hydroxide. That is also known as slaked lime. So, we will get a white PPT. So, white PPT of what? White PPT of calcium carbonate plus water. So, we can say the lime water will turn milky. So, whenever carbon dioxide gas is passed in the lime water, we will get a white PPT. So, the lime water will turn milky. So, this is a test for the carbon dioxide gas. First, see, here we got calcium carbonate and water. Suppose if excess of carbon dioxide is passed, so excess of carbon dioxide is passed, then see in the product what we got is calcium carbonate and water. If excess of CO2 is there, then we will get calcium hydrogen carbonate. So this thing you should remember. So adding more carbon dioxide result in the precipitate dissolving to form colorless solution of calcium hydrogen carbonate. Next, how is the presence of acid tested with a strip of red litmus paper? So we have two types of litmus paper. One is red litmus paper and another is blue litmus paper. So blue litmus paper, so red litmus paper, what it will turn? It will turn the for the bases. For bases, red litmus paper will turn into blue litmus. For the acid, what happens? Blue litmus paper will turn into red litmus paper. So here, what is the question? Presence of an acid tested with a strip of red litmus paper. So we have got acid here and we have to test the acid with red litmus paper. But red litmus paper is used to test the bases because there if we put a base on the red litmus paper, it will turn into blue color. So remember, blue. So red litmus paper is used to test the bases because it will turn red litmus paper to blue litmus paper. But for here, we have to test acid with red litmus paper. So if we are putting the acid on the red litmus paper, then there will be no effect. No effect will be the answer. Similarly, for blue litmus paper, what happens? If we put any acid on it, then the blue litmus paper will turn into red litmus paper. This is how we can test the acid and bases with the red litmus paper. Next question. You are given an organic compound having molecular formula C3H8. Give the name and formula of the compound formed. C3H8. Now write 1, 2, 3, carbon 1, 2, 3, 4, 5, 6, 7, 8. So this is C3H8. That is, it is propane. So first what we have to put? One hydrogen is replaced by chlorine. So what you replace one hydrogen with chlorine. So if you are replacing chlorine, so the answer will be what? It will be, we have to write the molecular formula and the name. So what is answer? Chloropropane. The answer will be IUPAC name is chloropropane and common name is propyl chloride. So molecular formula for this compound is C3H7Cl because we are replacing one hydrogen and in place of that we are putting chlorine. So C3H7Cl is the molecular formula. And the name is chloropropene. Next, B. When one hydrogen atom is replaced by OH group. So same thing, just instead of chlorine, we will put OH here. And again, in the molecular formula, put OH. So the name will change. So 1, 2, 3. So because it is OH is an alcohol, the name will be propanol or 1-propanol. This. So molecular formula is C3H7OH. Next, when one hydrogen atom of C3H8 is replaced by aldehyde. In place of OH group, you place aldehyde, CHO group. So again, molecular formula will change. So here, either you can write CHO group like that, or you can write full C double bond O H. Now, count the carbon atom here. 1, 2, 3, 4. So 4 means word root is but, and aldehyde is present in the first carbon, and name ending will be al. So the name will be butanol because it is an aldehyde. What is the molecular formula for this compound? So molecular formula, now count 1, 2, 3, 4. C4. Hydrogen count 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogen and oxygen 1. So the molecular formula for this compound is C4H8O. Next question. When hydrogen of C3H8 is replaced by COH group. So what is COOH group? COOH group is the carboxylic acid group. So in place of aldehyde, put COOH group. Like this also you can put, or you can write the full structure of that group, C double bond O, OH. So now first carbon is this. Because we know that while naming the compound, the functional group should always get the lowest number. So here, acid group get lowest number. So 1, 2, 3, 4. 4 carbon means the word root is but. So the name is butanoic acid. Then what is the molecular formula for this compound? Calculate how many carbons? C4. How many hydrogens count? 1, 2, 3, 4, 5, 6, 7, 8. So hydrogen is 8. How many oxygen? 2. So the molecular formula for this compound is C4H8O2. Next, what is the question? Next question is, when two hydrogen atoms join to the middle carbon atom of C3H8 are replaced by one oxygen atom. So one oxygen atom, let us replace it. Again, first write the formula of C3H8 only. So let's write the formula of C3H8. 1, 2, 3, all hydrogen, 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 hydrogen. Here middle carbon means you have to select this carbon. So two hydrogen, this hydrogen and this hydrogen. It should be replaced by oxygen. Replaced by oxygen. So oxygen. So carbon is tetravalent 1, 2, 3, 4. Oxygen also having 6 electrons. So these will be shared. This. So hence, this is, what is this? This is propanol. This is ketone. 1, 2, 3. This is the name propanol. Then what is the molecular formula? Molecular formula now count how many carbon? C3. Hydrogen. 1, 2, 3, 4, 5, 6. C3H6 and 1O. C3H6O. This is the molecular formula of the propanol. So hence you remember, like this we have to do. First, always start writing the structural formula. In that only you substitute the other groups. Next. Next question is, write the chemical equations for the chemical reactions and carbonic compounds obtained. First question, reaction of acidified potassium dichromate solution with ethanol on heating, reaction of sodium metal with ethanol, reaction of concentrated sulfuric acid with ethanol at 443 Kelvin. So in everywhere it is telling about ethanol. So we are studying here the properties of ethanol. So what are the properties of ethanol? That is we are studying about the chemical properties of ethanol. What is ethanol? It is an alcohol. Let's start doing the first question. Acidified potassium dichromate solution. Ethanol. First write the formula CH3, CH2, OH is ethanol. Ethanol. So what will acidified potassium dichromate solution will do? What is this? What is this? Acidified potassium dichromate, K2Cr2O7. What is this? This is an oxidizing agent. What is the function of oxidizing agent? It will add oxygen. It will oxidize alcohol. So first alcohol will always be oxidized into aldehyde. Again oxidation will take place and it will oxidize into acid. So ethanol will oxidize into ethanol aldehyde. Then again oxidized into oic acid, that is ethanoic acid. Another also is there. Another is alkaline KMnO4, that is alkaline potassium permanganate. It is also an oxidizing agent. The function of this is also same. It will oxidize the alcohol into aldehyde and aldehyde will be oxidized into carboxylic acid. So whatever it may be, whether it may be ethanol, whether it may be propanol or butanol. Suppose it is butanol, oxidation will become, after oxidation it will become butanol, and again butanol on oxidation it will become butanoic acid. So always remember, very important, key alcohols on oxidation will always give aldehyde and aldehyde on oxidation will always give carboxylic acid. So you remember this one. Next, reaction of sodium metal with ethanol. So write C2H5OH. We can write like this also, ethanol plus sodium metal. So whenever sodium metal reacts with ethanol, we will get sodium ethoxide plus hydrogen gas is liberated. So the answer is sodium ethoxide. You can write sodium ethoxide. Next question. Reaction of concentrated sulfuric acid with ethanol at 443 Kelvin. So write the full structure of ethanol. So whenever ethanol reacts with concentrated sulfuric acid. So this is which one? Hot, concentrated H2SO4 and temperature is 443 Kelvin. So concentrated sulfuric acid is a dehydrating agent. What is this? It is a dehydrating agent. Means it will remove water from the alcohol. So let us remove water from the alcohol. We are removing water from the alcohol. So after removing H and OH, so these two bonds will turn into double bond. So write full structure of this. So we will get this. And after removing H and OH, for this we will put one double bond. So we will get alkene. Which alkene is there? 2 carbon is there, right? So this is ethene. So this is ethanol. So remember always, alcohol on reaction with hot concentrated sulfuric acid, then we will get alkene. So sulfuric acid, concentrated sulfuric acid acts as a dehydrating agent. It will always remove water from the alcohol. It may be ethanol, it may be propanol, or it may be butanol. Any alcohol, when reacts with concentrated sulfuric acid, always water will be removed and you write the alkene. So here ethanol becomes ethene. So these are very important points. This is the concept you should remember. Next question. See, the same question is twisted in another way. A gas is evolved when ethanol reacts with sodium. So which gas is evolved? We have seen hydrogen gas. And also write the balanced chemical equation. Just now we have written the same thing. Ethanol reacts with sodium. We will get sodium ethoxide and hydrogen gas. An organic compound, A, is a constituent of many medicines, used as an antifreeze, and has the molecular formula C2H6O. Upon reaction with alkaline KMnO4, A is oxidized to another compound B with formula C2H4O2. So C2H6O, the same thing is there, C2, C2H6 and O. See here 1, 2 carbon, 3 plus 4, 5 plus C2. So this is also C2H6O. They have reacted with alkaline KMnO4. So what it will form? First it will form ethanol. On oxidation again it forms ethanic acid. So same. Butane antifreeze and has the molecular formula this. Upon reaction with KMnO4, A is oxidized to compound B. So compound B with formula C2H4O2. So C2H4O2, C2H4O2 means C2H4, 3 plus 4 and O2. This is C2H4O2. So same thing is twisted in another way. So this is oxidized to, so first what will happen? A is oxidized to, so this is A here, compound A is, we got is ethanol. Ethanol A is oxidized. So actually it is oxidized to first will be aldehyde, then again it will be oxidized to acid. So the final answer will be the B will be the, this is the acid, C2H4O2 is the, this is ethanoic acid. So hence compound A is alcohol and compound B is ethanoic acid. What happens when ethanol reacts with sodium? Same thing. When ethanol E2OH reacts with sodium, we will get ETONA plus H2 means sodium ethoxide and hydrogen. With potassium permanganate solution, same thing. What happens? Alcohol on oxidation with KMnO4. So first always it will go to aldehyde. Again it will on oxidation it will change into carboxylic acid. So the final answer will be it will be acid. Thank you very much.